Imagine this, you're hurtling through the cosmos, millions of kilometers from Earth. Your spaceship is suddenly out of control. Panic sets in as you see it ahead, a black hole. The darkness looms larger, swallowing light itself. No engines, no rescue, no escape. You're drawn closer against your will. What happens next is not just a theory, it's real physics. You're about to experience the unimaginable. Your heart races. You're not just a spectator, you're the astronaut in the story. This isn't a movie or some wild science fiction tale. This is the terrifying reality of black holes. The danger isn't merely in the darkness, it's what that darkness does to everything that gets too close. Brace yourself. What happens inside a black hole? It will challenge everything you think you know about space and time. Get ready to journey into the unknown. What is a black hole? Well, it's not a giant hole in space. Picture this, a region where gravity is so strong that nothing can escape it, not even light. Sounds eerie, right? Black holes form when massive stars collapse under their own weight. Imagine a supernova, an explosion of a dying star. It's beautiful, yet terrifying. But here's the twist. The real danger isn't just the black hole itself, it's the point where you can no longer turn back. Once you get too close, you're in a race against gravity. It pulls at you, stronger than anything you've ever felt. But why is it so powerful? It's all about mass and density. The more massive an object, the stronger its gravitational pull. And black holes are among the most massive objects in the universe. But remember, it's not just about what's inside. The real horror begins when you approach the edge. That's where the unimaginable happens. Imagine standing at the edge of a waterfall. From a distance, it looks beautiful. You can swim freely, feeling safe. But as you get closer, the current grows stronger. The water rushes with an unstoppable force. That's the event horizon of a black hole. It's not just a boundary, it's the point of no return. Once you cross it, there's no way back. Not even light can escape. You might wonder, how can that be? Think about how gravity works. It pulls everything toward it, and at the event horizon, that pull becomes incredibly intense. You float closer and closer, feeling the invisible grip tighten. But here's the thing, you can't see the event horizon. It's hidden behind the dark void. You're unaware until it's too late. You think you can still swim away, but nature has other plans. The current becomes a raging torrent. Once you cross, you're trapped. This is where the real terror begins. Now let's talk about spaghettification. Yes, it sounds funny, but it's terrifying. Picture this. Your feet are closer to the black hole than your head. That means gravity pulls harder on your feet. It's like being in a tug of war, but you're the rope. As you get closer, your body stretches. Longer, thinner, like a piece of spaghetti. But here's the shocking part. This isn't just a weird image. It's real physics at work. This extreme difference in gravitational pull is called tidal forces. Imagine pulling on a rubber band. The more you pull, the thinner it gets. Now, imagine that happening to your entire body. Your skin, your muscles, everything starts to stretch. You might feel the sensation at first, a weird, uncomfortable feeling, but soon it escalates to sheer horror. Eventually, you're pulled apart, atom by atom. It's a fate worse than any nightmare. You're not just fading away, you're being torn apart by the very fabric of the universe. And the worst part? You won't even have time to scream. You're at the mercy of the black hole, where the laws of nature twist and turn in unimaginable ways. But wait, there's more to this nightmare. While you're experiencing this horrifying stretch, time itself begins to warp. Imagine looking at a clock as you fall. It ticks normally for you, but from afar, it's a completely different story. If someone on Earth is watching you, they'll see you moving slower and slower. It's as if you're trapped in slow motion. You could wave goodbye, but it feels like you're standing still. But here's the thing, they'll never actually see you fall in. You'll appear to freeze at the event horizon, like a ghost caught in the moment forever. To them, it's an endless spectacle, but for you, it's just a regular experience, time flowing as it always has. This is called time dilation, a wild effect of Einstein's theory of relativity, and it gets even crazier. If you somehow manage to escape the black hole's grip, you could return to Earth years later. Centuries could have passed. The universe keeps spinning while you remain in your own pocket of time. Imagine coming back and finding that everyone you knew has aged decades. It's mind-bending. You're left to wonder, did you just step into a time machine? This isn't fantasy. It's the reality of what happens near a black hole. Imagine this. You're orbiting a black hole and time behaves differently. It's not just a weird theory, it's a reality. While you're floating there, maybe taking notes or just marveling at the universe, something strange starts to happen. Time stretches out for you, but for everyone back on Earth, it's a different story. You could be there for just a few minutes, but back home, years could pass. Yes, years. It's like being in your own bubble where time is a lot slower. This phenomenon is called time dilation, and it's a mind-boggling consequence of Einstein's theory of relativity. But here's the kicker. If you ever escaped and returned to Earth, you might find that decades have gone by. Imagine stepping back into a world where your friends have aged, maybe even passed away. You'd be left wondering, did I just step into a time machine? The universe is full of surprises, and this is one of the wildest. It's real and it's happening right now, even if we can't fully understand it. But what's inside a black hole? That's the big question. The truth is, nobody really knows. Scientists have their theories, but they're still trying to piece it all together. One possibility is a singularity. This is a point where density becomes infinite. Imagine squeezing an entire star into something smaller than an atom. Sounds impossible, right? But that's what current physics suggests. At the singularity, the laws of physics as we know them break down. It's a complete mystery. But here's the catch. We can't see inside a black hole. Light can't escape its pull, so we're left in the dark. Some researchers think quantum gravity could change everything. What if new physics emerges? This could redefine our understanding of the universe. The black hole remains a cosmic enigma. It teases us with questions we can't yet answer. What lies beyond the event horizon? The answer is still waiting to be discovered. Until then, the mystery endures. Now let's talk about the possibility of humans visiting a black hole. Spoiler alert, it's probably not going to happen. The nearest known black hole is more than 1,000 light years away. That's a distance so vast, it's beyond our current travel capabilities. Just think about it. Even with our fastest spacecraft, it would take thousands of years to reach it. And that's if we could survive the journey through the harsh conditions of space. But here's the thing. Even if we could somehow get close, it would be incredibly dangerous. The gravitational pull near a black hole is so intense that any ship would be torn apart. Imagine being pulled into a cosmic vacuum. You wouldn't stand a chance. So while the idea of exploring black holes is fascinating, it's also terrifying. The reality is that we're still bound by the laws of physics. For now, black holes remain out of reach. They're like cosmic sirens, calling us to explore but warning us to stay away. So what happens if you fall into a black hole? You cross the point of no return. Gravity stretches you in unimaginable ways. Time itself begins to act strangely. But here's the kicker. No one truly knows what lies beyond that event horizon. The universe keeps some secrets hidden. Imagine experiencing time differently than anyone else. You fade away while everyone on Earth watches you slow down. It's both fascinating and terrifying. We're left with more questions than answers. What happens at the singularity? What if new physics could change our understanding? It's a puzzle that challenges our comprehension of reality. Black holes are gateways to the unknown. They pull us in with their mysteries but push us away with their dangers. We may never visit one, but our curiosity will always draw us toward them. The universe is vast, and black holes remind us how little we know. They are a reminder of the wonders and dangers that lie beyond our reach.